6 students. Today we're going to review the most complex type of circuit that we learned in class yesterday. We are also going to review how to calculate the cost of electricity for something. And then in class we are going to cook Pop-Tarts 2 different ways, microwave and toaster, to see which one costs more money in order to cook them that way. Okay, so from before, this right here is a complex circuit because as we send our current, we start at the negative, the small side, and we work our way through. We can either go like that, or we can go like that. The series circuits are the ones that all the current goes through. So all the current goes right here. So resistor 1 is a series. Then it gets to here, it splits, making these parallel, but there's also these two that are series with each other, but parallel to this one. That is what was new this week. We have 2 in a row, but they only get the blue current, not the pink, so they're series with each other, but parallel to the other guy right here. And then finally, all the current goes back through, comes back together, and everything goes to resistor 5, so that will be a series circuit as well. I, once again, just get myself a place to put everything. All right, there are going to be 2 places where this differs. One is when we find the total resistance. So finding the total resistance, we still have to do the parallel ones first. So we are going to go 1 over 1300 plus, and then the only difference is because these are series, they're going to get added together first before they go 1 over. So we're going to have 1 over 1500 plus 800, which is 2300. Okay, so we are going to type into our calculator 1 divided by 1300 plus 1 divided by 2300. If you add those two together, you get 2300. You hit enter, that gives you a really small decimal. It was like 0.0012, something like that. That's not the resistance for those guys, that's 1 divided by. So we do the 1 divided by second answer, we hit enter, and we end up with a resistance for the parallel guys of 830.6. Okay, that's these 3. Then to that number, we add in the total resistance of the series, just normally, just like we always have done. We're going to add in the 1400 and the 3500. When we get a total resistance, I got 5,730.6. That is my total resistance. Immediately after that, I find the total current. I take the voltage of the battery, solve for I using my current or my resistance that I just found. And when I divide under to find my I get I'm going to go to 3 decimals. I get a total current of 0.262 amps. All right, so that's my starting place. The only thing that was different was before, when I do my parallel guys, I have to add together those things. That's truly going to be the only difference. There's 2 times where we're going to have to add those 2 numbers together first. Okay, now we go back to complex circuits the same way we always did. We now know all the current. We have 2 series resistors that get all the current. So automatically I1 is 0.262. All the current, and I5 is 0.262. I am going to take I times R, 0.262 times 1400. I'm going to get that voltage. I got 366.8. At any point, put pause on the video and you type these things in, check to make sure you know how to do them. And then once again, I times R for resistor 5, and I found a voltage of 917. Okay, so I'm going to go through and just pop these things in. I1 was 0.262, I5 was 0.262, V1 366.8, and V5 917. All right, from here, we do the same thing we did before. We need to find what voltage is left to go through these right here. So I'm going to start by following the pink path. If I leave, I go through resistor 1, resistor 2, and resistor 5, which means the voltage for resistor 1 plus the voltage for resistor 2 plus the voltage of resistor 5 have to add up to the total of the battery, which is 1500. I already know voltage 1, 366.8. I'm solving for what voltage is left to go through the second one, and I already found the voltage for resistor 5. Those three have to add up for a total of 1500, which is the voltage of the battery. Okay, if I subtract away, what's left is 216.2. So I'm just taking 1500, subtracting 917 and 366.8, and I get 216.2. And I'm going to put it right there. For resistor 2, I now have the voltage and I have the resistance. So if I want to find the current, I'm just taking the same equation we've been using over and over, 216.2, finding the current, and the resistance was 1300. If I divide, I get the current for resistor 2 to be 0.166. All right, here is where things change just a little bit. We are gonna do the same thing, but we're gonna follow the blue path this time. If I follow the blue path, I am going to have the same voltage left over to go through these two resistors because I now go through so blue path is going to go through resistor 1. It's going to go through 3 and 4. And then it's going to come back and go through resistor 5. And it's still going to equal the total of the battery, which is 1500. Okay, I now have two resistors to use up this voltage at, so I can't get them both. But what I can do is subtract away, and once again, I am going to get a voltage that's left to go through those equal to 216.2. It's the same as when you subtracted here. So my delta V to go that direction is 216.2. That's how many volts I have left to go in that way. Okay, unfortunately, it doesn't just get split. You can't just divide it in half. It gets split according to how much resistance there is. It's kind of proportional to it. All right, so what we do is, this is the second time we're going to add these resistances together. 1500 plus 800 is going to give us 2300. And we are going to set that resistance. We're going to use delta V. I'm going to try and find a spot here. We're going to use delta V equals I times R. We're going to take the voltage that's left to go through both of them, 216.2. We're going to find the current that goes through both of them, because what goes through one has to go through the other. There's no other choices. And for the second time, we are going to use the resistance of the two of them together. Okay? Both times you use their voltages, you have to, or their resistances, you have to add them together. Once at the beginning to find the total resistance, and once now to find the total current. Okay? If I divide under, if I take the 216.2, divide it by the 2300, that combined resistance, I get an I of 0.094. 0.094. And 0.094. Whatever the current is that goes through one, it has to go through the other. They have to be the same. There's nowhere to split. So I have a current for each of them. My last step to find how the voltage splits between them, I take the I and multiply it by the R to get this V, and I take the I, multiply it by the R to get that V. So if I take 0.094, multiply it by 1500, I get 141 for the third one. And if I take 0.094, multiply it by 800, I get 75.2 for that one. It takes more voltage to get through the third one because there's more resistance. We didn't need as much voltage because there was less resistance to push through. All right, so that's a review of yesterday and what we learned in class. Now, we are also going to review electricity. So at a gas station, the hot dog roller machine cooks hot dogs for customers all day long. The machine is 1,350 watts. How much does it cost to run the hot dog roller for 24 hours? Okay, so anytime we're looking for cost, the only equation that we use is our power equation. Power has to be in kilowatts and time has to be in hours so that we can solve for the work in a kilowatt hour. And then, whenever we know how many kilowatt hours it is, we multiply it by the 0.101. That's the price per kilowatt hour. Okay, so that's going to be our plan. We just have to get our units to line up. So the 1,350, normally we want watts for power, except when we're finding the price of something. We have to change that 1,000 watts in a kilowatt. That goes to 1.35 kilowatts. Divide by 1,000 to change to kilowatts. We want to know the price for 24 hours. Their time is going to be 24 hours. We don't have to change that. We're already good. And I forgot to put, but the watts are the power. So I have the power and the time. I have to multiply in order to find the work done. All right, so I'm going to put my power in, 1.35 kilowatts. I'm going to set it equal to the work done, divided by the 24 hours. I am going to multiply to get my work in a kilowatt hour. So if I take 1.35 and I multiply it by 24, I get 32.4 kilowatt hours. And then my last step, that's how many kilowatt hours we have. The price for every kilowatt hour is 0.101. So my final answer is 3.27. That would be dollars. $3.27. If it were in cents completely, you just multiply it, move the decimal 2 spots. There's 100 cents in a dollar, so you multiply it by 100, which is 327 cents. On the back side, it's not going to cost as much to cook a Pop-Tart, so we'll put it into cents in order to kind of see how it goes. All right, so that's a review of our most complex type of circuit and also how to find the price of electricity. If you were not in class today to do the Pop-Tart lab, then just make sure you use the data that's inputted on the back of the lab. Thank you.